Let's try to use our knowledge of power series so far to find a power series representation of the function h of x equals 1 over 4 minus x. Again, we're going to use our knowledge of the geometric series. 1 over 1 minus y is 1 plus y squared plus y cubed, etc., etc. And it's the sum of y to the n for y between minus 1 and 1. H of x, our function of interest, is 1 over 4 minus x, and I can actually pull out a 4 out of the denominator there, and I get 1 over 4 times 1 over 1 minus x over 4. With y equals x over 4, if I substitute that into the expression above, I get 1 over 1 minus x over 4 is 1 plus x over 4 plus x over 4 squared plus x over 4 cubed, etc., etc. And it's the sum from 0 to infinity of x over 4 to the n, which is the sum of x to the n over 4 to the n, whenever minus 1 is less than x over 4, which is less than 1. So this formula works for x values between minus 4 and 4. That's just multiplying those inequalities across by 4. And for x in that interval, I have 1 over 1 minus x over 4 is the sum from 0 to infinity of x to the n over 4 to the n. It's also clear that this series diverges the endpoints. If I plug in 4 or minus 4 here, the 4 to the n's will cancel, and I'll be left with the sum of minus 1 to the n or the sum of 1 to the n, both of which diverge. So the radius of convergence of this power series is 4, and the interval of convergence is the open interval from minus 4 to 4. And now my original function was 1 over 4 times 1 over 1 minus x to the 4. So the power series expansion for that is 1 over 4 times the power series expansion for 1 over 1 minus x over 4. And that's equal to the sum from 0 to infinity of x to the n over 4 to the n plus 1. That's multiplying every term in the above power series by 1 over 4.